We'll get started here in just a couple minutes after everything gets going. The camera's closer and it's a little weird. It's good though. I'll say some hellos while we get going and pause my videos here. Although my camera froze. You can probably still hear me. Let me unplug and replug it back in. Freeze tube. That hasn't happened in a while. Let's see if I can't. Now I'm moving again. We'll see if it stops. It's so cold the camera stopped. Hello Unexpected Maker. Hello Deshipu. Hello Grig. Hello Michael. Hello Pierre. Hello Eric. Hello Grig again. Hello Larry. Let me know if my camera stops again, please. Hams Lab says, great, good news in my world. I finally got a job. Congratulations. Hello Charles. Hello Keith. Hello Dexter. Hello Anthony. Yeah, hopefully it cooperates. Yeah, not been a huge fan of the weather here. I'll try rain and warm over cold in the morning, cold and foggy in the morning, and sunny and not very warm later. Hello Michael. Hello Tammy. Hello Megs. Hello Paul. Oh, hello Dave. All right, well, that was fun. Hey, Thomas. Hello, C. Grover. What do we think? What do we think? See, the camera is like well within my arm's reach now. Hello, Dinkelberg. Hello, Maiko. All right, let's get going. And yeah, let me know if the camera stops again. All right, so hello everyone. My name is Scott and I work on CircuitPython for Adafruit. If you don't know, Adafruit is a open source hardware and software company based out of New York City, but I work remotely for them in Seattle. So here I am in Seattle. The sun is out. The cat is enjoying the sun in the corner there. And yeah, so they do open source hardware and electronics. If you want to support them, you can go to adafruit.com and purchase stuff there. They pay me to do these streams and work on CircuitPython throughout the week. CircuitPython, if you don't know, is very sharp image. Good. I love this camera, so I figured it would just be better. I feel like it's a little darker. Like it's usually like better lighting than it is now, but you know, oh well. So CircuitPython is a version of Python, which is an easy to use programming language. And we built on MicroPython to provide that ease of use on microcontrollers, which are these little tiny computers that are basically in everything here. So this is a Wi-Fi and a BLE capable microcontroller here that we're working on. And yeah, so, oh, some people. Yeah, so that's what CircuitPython is. A lot of you are regulars, so I'm sure you know that. This is a deep dive. It happens every week, normally Fridays at 2 p.m., unless I'm taking the week off. And it typically goes for about 2 hours. So we're going to shoot for 2 hours. I've got plans to play some video games after the stream here with a friend of mine. So we're going to shoot for 2 hours. Questions are welcome. We'd be happy to try and answer everything. I make no promises about my ability to actually answer it. And then last up on housekeeping, all of the notes for the deep dives, because they're so long, David is gracious to take notes as we go along so that later on you can look into the video what parts are what. So all those notes are available on GitHub. You can go github.com/adafruit/deep-dive-notes. And Patrick has been doing a great job collecting all those there and making them linkable. So thank you to both David and Patrick for making that happen. That's all the housekeeping. So let me just get a little more caught up on chats and then we'll recap stuff. Greg says, I recently used some of what I am learning in Python to navigate a bad router web interface using the module mechanize to auto-reboot it via command line. Because if I don't, it eventually freezes and refuses connections. That's clever. Is that mechanize does that? Oh yeah, David's, yeah, mechanize does it. It probably uses a browser to actually click stuff. And then DCD says, if anybody has links that they want in the notes, just put them on the Discord and David will put them in the notes doc. Mark Tomlin says, hey Scott, just got an AMD 5950X and I gotta say great chip. After watching you compile code in the blink of an eye, I had to snag one. Yeah, I've been very happy with it. I'm starting to realize how nice it is to just have a really good computer to work on. And so thank you to my GitHub sponsors. I do have GitHub sponsors as well. And I'm kind of treating that as my like upgrade my computer fund. Python module emulates a browser. Neat. Yeah, so thank you to all my GitHub sponsors as well for supporting me. Adafruit's by far pays me the most, but thank you to the sponsors as well. All right, I don't actually see any questions, so if you have questions, feel free to ask them. We can take a quick detour here to CatCam because Dinkelberg says the CatCam, yay. So here's full screen CatCam. Sun is out, which means that Spook is laying in the window there, stretched out because he's hot. And then what you can't see is that under that cardboard cat thing, there's a heat vent. So it's been cold and sunny, which means the heat's still on. So he's been super happy getting all the warm air blowing right on his feet while he lays in the sun. So it's a good cat life, I'll tell you that much. Hello, Andrew from Cornwall. Okay, well, let me go to the desktop. And one of the things that I wanted to talk about was just to start from where we left off with CircuitPython 22. I was going to shoot to have this be the last day, but Kattni hasn't done it yet, and so she's still going to do that. So I'll probably do the final post next week sometime when I hear from her and anybody else who's still working on it. But if we go to the blog and do tag, I think the last one we talked about was cats are heat seekers. Yeah, the camera looks professional. Good. I love this camera. I think my lighting could be a little better. Like this side of my face is a bit dark, but details. I think we left off with Ken. Was it Ken or FoamyGuy? I don't actually remember. So if you missed it last week, CircuitPython 22 is our kind of annual planning chance. So it's our chance to talk about what we'd like to see for CircuitPython in the next year. So I did my post and talked about it a couple weeks ago, and then we've gotten a number of folks since then. So I figured last week I recapped everybody else, and so I wanted to just highlight the last few that we got over the week. So let's just go through these. I think we did talk about Circuito. I think we did that already. And then over the weekend. I think it was FoamyGuy and deshipu. But yeah, if folks have questions, feel free to ask them too. So I guess I could say something for FoamyGuy too. So FoamyGuy says it was their second year involved, and FoamyGuy's just been doing a lot. And things that they wanted to call out was adding bitmap tools, boundary fill, doing automated type issues stuff, and the library project screenshot utility. So that's like super useful for updating learn guides to show you like these are the files you should have. We actually have an auto generator for that now. Things that FoamyGuy is looking forward to. So it's exciting that FoamyGuy is going to be dedicating Mondays to working on CircuitPython. So Adafruit is paying FoamyGuy part-time for that. So that's really exciting. Things that FoamyGuy wants to do is get more comfortable in the core. Particularly to make some things that take file objects take file names so that they own the objects. Continue building out display I/O helpers to make it easier to build rich GUI applications. Gain more knowledge about bus device communication with the aim of being able to write drivers for new and existing breakouts. Improve the information available on the board module and the stubs, and get involved with working on the BLE workflow for the native Android app. Yeah, so Ham's Lab, is there a way for you to submit suggestions? So generally the way this works is just post it somewhere. So if you have a blog, you could post it there. If you want to just do a GitHub gist, you can do it there, like what FoamyGuy did. And then just email circuitpython22@adafruit.com. That's a like mailing list internally that will go to Phil and I. So when I see that, I'll do a blog post that links other people to it so that they can see that. So there's a couple interesting things for FoamyGuy's CircuitPython 22. One is the mention of the Android app. We actually just decided to start working on that. So the person that we contract for a lot of the mobile app development, Antonio, did FileGlider for iOS, is now has just started working on a FileGlider for Android. So that should be cool, and we'll hear more when that makes more progress. He's just started this year on that, so that's exciting. And then the other thing that I wanted to mention that's tentatively in the cards is that I mentioned on a few past streams that I'm going to be out a lot this year because I'm expecting my first kid. So I'll be out starting in March sometime, depending on when the kid comes. And what we just kind of looked at is that it looks like FoamyGuy is actually going to start streaming in this spot on this channel on Adafruit. So those of you who like this time for deep dives, FoamyGuy will be taking the torch for me, hopefully. I don't want to like super commit him to do it, but he's tentatively said yes to it. So we'll get FoamyGuy in this slot on streaming for Adafruit, which will be awesome as well. While I'm out, and then I honestly don't know what's going to happen after I come back. So FoamyGuy might continue that. We'll see. All right. So that's FoamyGuy's CircuitPython 22. Next, well, we didn't actually touch on Keith, did we? So KeithTheEE sent this one in today. Not this one. This one. Also a gist. And I thought this was neat to see like the sort of projects that Keith is working on. So a lot of like home automation sorts of things. But then I think Keith did a good job of touching on like the community is really awesome. Generally, our documentation could be a better structured. So there's like really good high-level tutorials of learn guides, but then there's like the API reference, and there's not a lot in between. So that is pretty interesting, and I think that's a good idea. And KeithTheEE definitely has a Python background, so I'm curious to see where they take like how they bring their Python experiences to CircuitPython. Um, ignore my complaining. Oh, I'm not going to ignore it, deshipu. I think you had good points. We'll get there. So another thing that Keith pointed out is time, date, and RTC. So talking about some challenges going from CPython world into that, into CircuitPython's timekeeping stuff. Timing sensitive multi-core JIT. This is an interesting idea that I'm not exactly sure what it means. But the idea of being able to like run things in a like real-time way. Oh, and Keith's in the Discord. Scientific CircuitPython. This is not the first. Keith is not the first person to talk about scientific CircuitPython. I think Keith here makes a really good point of like, it doesn't need to be bulletproof, but like a lot of people can do science if there's like some hand holding for the sensors and stuff. And I think that's, and talks about how the strength of CircuitPython is making it easy for like people who don't code primarily. So yeah, scientific CircuitPython, microlab and beyond, some more stuff that I don't understand because I don't know this detailed statistics stuff. But yeah, some cool things there. We got a question in the chat from Dinkelberg. Says, when will the floppy disk support be finished for CircuitPython? Also, congrats on the kid. Thank you for the kid. I don't know the status of the floppy disk support. Jeff and Jeff and Lamore are doing that primarily, so I'm not sure what their plan is exactly. I asked them about 8-inch floppy support because my uncle actually has a bunch of stuff he'd love to try to back up. But they are still working on 5 1/4. So I think that there's a floppy IO. Is it a pull request still? I think it might be a pull request. Yeah, there's a draft pull request for adding the floppy IO module. So that's, if you want to follow along, I'd suggest going here and hitting subscribe. And then you'll get updated when this... you'll get updated when work continues on floppy IO here. Let's go back to... Tammy points out, it depends on your definition of finished. I'm never finished with I never finish anything. I just decide that I'm done with it. So let's see. More specifically, Keith is talking about scientific in terms of LoRa, low power, heavily used in remote scientific studies. A lot of those experiments are designed by folks without an EE background. I think CircuitPython could extend a path for data acquisition that Arduino and Raspberry Pis have opened up. Yeah, 8-inch floppy. Well, it's like code that he wrote in like the 70s or 80s. What's next? Paper, tape, and punch cards? I don't know. There was somebody doing punch cards, I think, on the forums. Michael says, is there a way to get the BLE date time in CircuitPython? For a recent project of mine, I used Arduino code to update an RTC when connecting the nRF52840 to an iOS device. Yeah, so what you need to do is, it's the current time service, I think is what it's called, on the phone. And in fact, I think I saw that. I think we do actually have an example of it. So all these examples would be in the Adafruit CircuitPython BLE repository. And yeah, there's a BLE current time service. And this is reading it, not writing it. So that's what you want, Michael, is the current time service stuff. Punch cards and paper tape could be read via OCR. Core memory. There was somebody trying to do core memory on the thing too, I think. Keith says, the JIT is just a silly idea, but I figured I'd think about it and mull it over. It's a flag, so the compiler treats the following code differently, which means it'd be a headache and a half just to add to the core. It sounds also like if you look at the native decorator and the Viper decorator that MicroPython have, where they like do more work to run it up front. Okay, let's keep going. Let's get deshipus out of the way because he's not super excited for me to go over it. Decorator. So let's see what deshipu says. Lots of keyboards, has a library called microkey. It was cool that we now support caps lock keys and disabled disk, keypad module, boot modes, all that stuff. No software progress on the walking robots. Camera breakouts aren't working still. Oh yeah, there's a SAMD 21 problem that we still haven't fixed. There is also a bug in the PWM code on SAMD that makes it hang completely in a loop waiting for a register flag that never gets set. I got that far debugging it, but why it never gets set is a mystery to me, and nobody seems to be interested in fixing it. I worked around it in the stage library by simply setting the backlight pin high, not using PWM at all, but I got bitten by the same bug recently in the Ocarina code. Yeah, it's tough. It's tough to prioritize fixing bugs, especially when it's only one person that's hitting it. Sorry. It's tough. Yeah, we have like 480 open issues. So. The future, fluff bug, camera support. A new S2 board, but the display is non-consecutive 16-bit. The Cool Watch project, is the Cool Watch project the one that Joey's doing? That has a SAML22. I feel like somebody was working on SAML support and they never got it in. I think it might have been maybe the Electronic Cats folks might have been working on SAML22 actually. I know you're not blaming anyone, deshipu. I do think, like, and we've talked about this before, like, it would be better for us to have a better way of doing automated testing so that for things like that, we'd know immediately that it was a problem. I think that's exactly this. Oh, and you know what? I did add an issue flag for regression, so maybe we should do that too. Oh, SAML22 can do LCD driving. That's really cool. Yeah, and I think the S3 is going to be cool too. I know you're talking about the S2, but the S3 is going to be really neat too. Hi, Roy. Where is the spammer? Is it hidden because I'm looking at top chat? No. I try to mod as the stream goes. I just see a hello from Russia. I don't see any spam. Am I missing it? All right, so this is from MD Roberts 1243. Says, I imagine CircuitPython becoming very easy to create serious IoT sensor nodes. CircuitPython with Adafruit sensor breakouts could be used to code the sensor logic. The ability to work over an RTOS so that a proper communication stack could be implemented in the background. This is successful in the ESP series, but I'd like to see STM32 or Nordic chips support the same. For a specific example, think of LoRaWAN. And then I followed up with MD Roberts here about like what the best info for doing LoRaWAN is. I think I was thinking about this actually as like if we had an RTOS under CircuitPython, what would that actually mean? And I'm not exactly sure what it would actually entail. Like, would that allow us to do more async stuff, or like we have it like CircuitPython is just us chickens. Yeah, so I'm not sure. We've talked a lot about doing RTOS stuff in CircuitPython, and I'm not sure what that actually buys us. I don't know why we would actually use it. I don't see any spamming yet, so. All I saw was a hello. Aren't there LoRaWAN featherwings? I think there are. I think the LoRaWAN support, I think we have LoRa support just from a library. It's not native at all. All right. Yeah. I'm here to mod if we need it, but we don't need it yet. Although YouTube did catch one thing that I blocked. Not from that person though, from somebody else. Okay, let's keep going. Yeah. I think we're all on the right track here. Usually the spammers I see when I'm streaming are on Twitch. I think pretty much every week on Twitch we get a like pay for followers spammer that then I ban. But all right, let's see. Molecularist has one big wish for CircuitPython on 22. UDP. I want to see deep sleep spread to all CircuitPython chips. And the biggest one is the more audio in support. So having the ability to do audio input would be really great. And that's something we've had an issue for ages before. It's just, I'm not a huge fan of doing audio work because I struggle with the signal processing side of things. So yeah, I think, this person also points out the like audio stuff in Teensy, and Paul's done an amazing job there. So I think it's good inspiration, but I'm not sure who the right person to really carry that forward is. So if folks have ideas and want to work on that, we'd love to have it. Love to have more stuff in CircuitPython for audio. Just not quite the right person to do it. All right, next up we have Tammy, who's in the chat. Hamslab says, I may do that. I love audio stuff. Audio in would enable 64 Commodore 64 cassettes. Yeah. Love to see Teensy Audo Library ported to CircuitPython. I looked at it like a little bit, like actually just using it, but the problem is that it really is built on top of the Arduino libraries, and I just don't know what that involves. Mark says, people always ask for UDP support, but never sure if anyone is listening. I thought UDP worked, but yeah. Oh, one thing when I was looking at the Teensy Audo Library is it does a lot of buffer allocations at compile time, I think. I think I looked at that and there was like a lot of static buffers and stuff, and that's a problem for CircuitPython because you don't want to use the RAM until you know you're going to actually use it. Hamslab says, I'm also going to make an audio featherwing with 2 in and 2 out, and might do balanced inputs if I can fit the connectors and get the chips. Yeah, I think, yeah. If anybody needs help getting started hacking the CircuitPython core, please let me know. We're always looking for more folks to contribute. Yeah, static buffers. Yeah, that was one of the things, is like so much code is written that like you're compiling it because you're going to use it when that's not usually the case, not necessarily the case in CircuitPython. Yeah, that's what the UDP joke is that UDP does not involve like confirmation that the other person heard it. I mean, isn't it like unreliable data packet or something? I may need some help getting set up. Is there a guide? Yes, Dan wrote a building CircuitPython guide. So if you want to just get set up building CircuitPython, that's the place to start. Whoa, that was a big... UDP is shouting into the void. Do you have books you recommend that are helpful? Books for what? Toddbot says, wait, what's the UDP joke? I think I missed it. Mark said, I could repeat the joke, but still wouldn't be sure if you'd get it. Kanto Robo, welcome. Never used CircuitPython, seems super interesting. What do you guys recommend buying to get into this? So somebody on the forums just asked this, and there's a guide for CircuitPython boards. Which CircuitPython board is right for you is a good place to start. If you have an idea of what you want to do with it, let us know, and we can try to point you in the direction that will take you there. But this guide that Kattni wrote is one of her many awesome guides that she's written. Tammy says, this meta humor is too much for my brain on a Friday of a week I've been on call for work. I know, right? It's fun though. I enjoy it. Okay, speaking of Tammy, let's go over Tammy's CircuitPython 22 before I get too distracted again. So Tammy says, holy cow, the Circuit Playground Bluefruit's amazing, has sensors and connectivity, and is $25. CircuitPython continues to be a game changer. Thank you, thank you, thank you. Hard to pick boards. Oh, there you go. We just talked about that. Things I'd like to work on in 22. CircuitPython dependency management tools. Circup is great, but we could have more metadata about the boards in the libraries that are for a given board. Something like pyproject.toml, but for CircuitPython. Twitch maker streaming. I love the fact that Twitch has grown beyond video games, and Tammy's shooting to start streaming by the end of February, so I'll post this link in the chat if you want to follow Tammy. Tammy's streaming that will be coming later this year. CircuitPython for Magic. Oh wait, I skipped one. CircuitPython hardware for music. More synth stuff would be great, and I know Toddbot and JP would be on board with this, and Blitz City are all music folks. CircuitPython for Magic. I think this is really cool, and I think JP does some of this as well. So like using microcontrollers is part of magic tricks, which I think is neat. Getting better with display I/O. The kind of de facto guide that Carter did has been hugely helpful, but I agree that there is definitely more to do there. And like the graphics team sort of folks from the community have done a really good job of making widgets and layouts and stuff like that. So it's come an amazing amount after I basically stopped working on it. So that's been really cool. Contribute more to the community. Well, you're here. Thank you for joining us, Tammy. I'm hoping to get all the rest of the streaming mechanics figured out this weekend. Yeah, and if you have questions, feel free to reach out. I obviously at least have this set up. Design a CircuitPython board. Yeah, this is something I've seen a number of people do, and it's super fun to design your own board and see the software come up. So, and KiCad's great. I've just used KiCad 6 a little bit, and I just opened it to like open some source files from Lady Ada, and I was really impressed. Like KiCad 6 looks really good. I actually need to get back to making something. Kanto Robo says, I will read the tutorial and try to make cute robots. I will try to document my journey. Awesome, yeah. And if you're not aware of it, Adafruit hosts Show and Tell every Wednesday where you can come show off your cute robots so that other folks can see it too. Books that help with problems you run into with core development. Discovered that reading through books is one of my preferred learning methods. Ooh. It depends on what you're doing. I really like the... If you want to know about Cortex microcontrollers, one thing is these books. Okay, see if I can reach it without unhooking myself. So here's a couple books that I like. If you want to go deep, there's this book, which is ARM Cortex M3 and M4 reference. You're not going to want to read it end to end, but like the intro stuff can be interesting. And then another book that I do use kind of as a reference too is USB Complete. So if you're doing USB stuff, this is the book for you. Really, really good reference book. But I don't know, like software changes so often that books are not always the best resource. But yeah, as somebody pointed out, like the Discord's a great place. So we have the CircuitPython dev channel. If you have questions about core stuff, we're always happy to get folks going. David says, I'm reading the USB Complete right now. It's very good. Yeah, it's a great reference. Tammy says, I was super excited to get involved with CircuitPython in 2019, and then the world blew up and my body tried to assassinate me last year. Now I'm excited to get back into the community. Well, I'm glad you're on the up and up, and I'm glad you're back. We're here still, although I guess I'll be gone some this year. But there will still be lots of other folks in the community that'll be great. Time code on those books, please. Yeah, we can double check here. Yeah, David's got it. USB Complete. Okay, so that's, I think we recapped Tammy's CircuitPython 22. Pierre says, I still have to upgrade to KiCad 6. Looking forward to all the positive changes they've made. Deshipu says, KiCad 6 is much better, but you still should start with a schematic in it. I hope they will improve the schematic-less workflow at some point. Interesting. I usually do the schematic first, but I suppose if you're doing something super basic, you don't necessarily need it. Oh, I think that was the last one, because we already talked about Keith's. And that's when this one is too. So it sounds like a couple of people want to keep doing this, so please try to get it in by like Monday next week, because I do want to kind of wrap it up, and it's good to have a deadline so that people do it. And Monday next week is actually the last day of the month as well, so I think that makes sense. Okay. Any questions before I talk about the ESP32-S3 and Bluetooth? And I'll wait for it to echo through the fiber pipes. Phil's Lab has a KiCad tutorial on Udemy, and it's free for a few days. I rarely start without a schematic. Good to know. I like to explore which pin's best used for what and such before I do the schematic. Yeah, I think what I find is that I end up laying out my schematics kind of like the board. Like I like my symbols to reflect the actual layout, which I think more traditional EEs like generally like their schematics to be more abstract. But I'm kind of like, I kind of want to be able to do that planning from the schematic. Will AMPI be supported for the ESP32-S3 workflow? I don't know. I don't know why you need to, because the S3 at least has the S3 has native USB, so you don't need it. For the C3, Jerry pointed out that AMPI didn't work, but I did a fix last week so the C3 should work with AMPI now. Oh, those KiCad tutorials are no longer available. They ran out. Toddbot says, I'll have a CircuitPython 22 post, but I'll be done maybe this evening. It's really just more audio control, please. Okay, thanks. Yeah, I don't know if he's going to do the audio stuff. Like, Jeff is doing a lot of floppy work, and Dan is doing the USB stuff right now, adding a second drive over USB. And depending on how this BLE stuff goes, it may not be finished by the time I need to disappear. I thought I was going to be pretty good, and then I just ran into some stuff today where it was like, oh, the Nimble stack doesn't support it. So I'm a little bit more worried that I'm gonna run into some like, I've got to work on Nimble things, which I may not actually get to by the time I have to take care of a child. All right. Pierre says, for the NR52840, with few exceptions, Crystal, Reset, SWD, and ADC, any GPIO can do anything. Yeah. Yeah, they have that full mux in the 840, which is pretty neat. They have some constraints about high speed, which pins can be doing high frequency stuff too, like native, relative to where the radio pins are. Toddbot says, I'm almost able to write native CircuitPython libraries now that dig into system resources, so maybe I can work on audio stuff. That would be amazing. It would be amazing to have better audio. I took a lot of inspiration from Paul's Teensy stuff, even if I didn't copy it directly. Like trying to have like functions that take buffers in and out and do stuff. But yeah, it's a little tricky because that like the audio pipeline also wants to be able to handle like looping. So you could say like, oh, I want to loop this sample, and you have it all in memory. You don't need to recompute how you got the sample necessarily. Oh. Dylan says, I'm relatively new to using CircuitPython, and I haven't had a chance to write a CircuitPython 22. It's great for the keyboard stuff I've used it for. I'm wanting to try it for some robotics-related projects. Nice, and it's important to note that like you can, if you're new to CircuitPython, a lot of what we want to hear is just what projects you want to work on, so that we can make sure that they're doable from CircuitPython. Neurodoc says, an issue with AMPI is that the latest imports Ubin ASCII to be binary safe. Jerry has filed a PR for that. I thought we already, didn't we merge that in already? I guess we didn't. Tammy says, I don't know if I know enough of the low-level stuff to contribute to the audio stuff, but it's something I'm interested in too. Hams Lab says, oh man, a looper would be great, especially after I finish my board. Oh yeah, I didn't mean like recording a looper. I think that's primarily what Molecularist is talking about. Mark says, I wonder how much of the audio stuff can be done port independent. I know a bunch of it ends up port specific, which makes the work harder. File transfer over I2C. I haven't thought about file transfer over I2C. Ron says, is there a good book on the ESP32-S3? Book, I don't know of anything. That chip's pretty new, and there is just the data sheet and the technical reference. But I'm not sure what you want to know about it. Let me just try to give a little bit of an audio code tour, because there's a lot of people saying they want to get into it, so maybe I can just be like, because I'm pretty sure, so here's the GitHub repo, and I'm pretty sure most of it's in, so Mark is talking about how much of it is port independent and port specific. Good night, Kanto. Dexter wants a swarm of multi-processing CircuitPython boards. Roy says, better understanding or guide for KMK software, keyboard software maybe, and RGB in it. I'd recommend asking the KMK folks, although Eva's been doing some KMK stuff for CircuitPython, or for Adafruit. I find it to be a little complicated. I need to get back to doing my keyboard because I do want to switch to it. Charles says, I hope to see USB hosts soon. Me too. I don't think that, I doubt USB host is going to get anywhere near, like, unless Dan picks it up, like, probably not till the end of the year at the earliest. Okay, so quick tour. So in shared module, this is where like code is shared amongst things. And so you'll see like there's audio core and there's these raw sample sources. So getting and setting sample rate, channel count, and then there's like this get buffer done, and then there's get buffer structure. I think this is kind of the core of the audio APIs, is that there's this like, give me a buffer. So it's meant to be driven by the outputs, which is why input is not that well supported. But this stuff is meant to be more about, like, say you have a sync, so something that's outputting audio and it has to request chunks of audio in order to DMA it out, right? And so that request is meant to kind of cascade through kind of an arbitrary set of transformations, which is kind of what the Teensy Audo Library is doing. And so there's this, I think it's mainly this like get buffer structure thing. And the get buffer structure thing tells you like whether your samples are next to each other or whether it's two different channels that are like alternating, basically like stereo or mono. And you can see that here it's pretty simple. And we have this notion of single buffer. So this says like, oh, by the way, like if you get a buffer, you're going to get the same one back, which means that if you did a transformation on it, that transformation could be cached basically as well. So that's like raw sample. Wave file is more complicated because it's going to be reading from the file system, but it has, I guess, reset buffers new, but it also has this like get buffer call and then a get buffer structure call still. So I think that's, so these are the things where like sound originates, and then there's audio mixer, and there's like, the mental model I have for mixer is that you have like any number of voices or like channels on the mixer, and then for each channel you can do something. It's been a long time since I did this. But you can see it has pretty similar, like, get my sample rate. Mix down one voice. Yeah, but there's still this, like, get buffer call again. And then there's a buffer structure as well. So it's kind of like you're building all these objects up and they all have the ability to, like, get a buffer and output it. Depending on the math needed, the hard stuff gets into the port specific code. Yeah, if you're trying to optimize based on assembly instructions. Mixer voice. Audio PWM IO. Nothing. Yeah, so Jeff's the last person that was in here. But then again, you still have this get buffer structure thing. And then if you're looking for outputs, the outputs will be port specific because they'll depend on the board. So like if we go into Atmel SAMD Common HAL and we do audio bus, it has PDM in and then I2S out. Dexter says kick on voice 0, snare on voice 1, mixer works pretty well. I'm not a math ninja either, Tammy. I feel ya. So like here's how I2S out works. So it's got this play, so you would give it a sample, and the sample here is, maybe I should make this bigger and make sure I'm showing it. So what you would do is you would kind of have like this tree or network of audio generation classes, and then you would call like I2S out play, and then it's going to figure out like what's the sample rate, clock the thing that's doing the outputting at that sample rate, figure out how many channels there are, depending on the channels, set up the output to be the same amount of channels, and then setting up audio DMA. That might be, I think that's shared because the DMA on the SAMD21 is this, like, very, like, you could use it for multiple ways to output stuff. Where is this defined? Oh, you know what? We can use this. I got my invite to code search on GitHub. So Raspberry Pi has its version. Atmel has its version. Here's the implementation. So this is what it looks like on the Atmel side. Setting up a DMA descriptor, getting the structure of the buffer. So that's something we saw in the mixers and things. We reallocate our two buffers. So like we're doing a double buffering, so we're alternating between them. And setting up clocking for it. And then audio descriptor. That must be the DMA still. Trying to find where we actually load the buffer. DMA callback function, DMA load next block. Oh, come on, I can't go to it. I know they have this nice. No? There it is. If you're zoomed out far enough, you can do this search for that. And if we find it, this is where it's calling the audio sample get buffer. So that's calling into things and getting the buffer back out and then DMAing it. Hopefully that gives you a little bit of an idea, but obviously it's not something I worked on recently, so I don't have a lot of brain cells dedicated to it at this point. Ron asks, what do you think about the ESP32 by best-selling author Eric Bartman? I have not looked at it, so I don't know. My resource tends to be data sheets and technical references. That's usually the resource that I usually look at. IDF, the ESP IDF has pretty good documentation too. Oh yeah, and Pierre's a keyboard person, so can help with CamK. Are there KiCad parts defined for the feather connectors? I have some somewhere. I don't know if they're correct. I don't know what the best way to do it is. But if you wanted like 3D models, they're just standard pin headers. All right, well, if anybody wants to take a look at the audio code, it would be awesome. CircuitPython Dev on Discord is a great place to do that. And oh, I didn't say this I forgot this in housekeeping. If you're watching on YouTube but aren't on Discord, you can join the Discord by going to the URL adafru.it/discord. And then the middle box now above me is the live broadcast chat channel for that. And that's great. The great thing about Discord is that it's chat that's around all the time. And it's been growing and growing, and it's a great resource for folks. So I like replied to multiple issues today being like, are you on the Discord? If you have questions, like that's the best place to ask. Okay, so let's go through, give an update on the status of BLE on the ESP, and then I might just try to work on it for the remainder of the stream, unless people have requests for what you'd like to see me do. Otherwise, maybe I'll try to like make a little progress. It's really hard for me. Okay, well let me not finish that thought and instead give you the background first. So this week, I think since last time, what do we have? I added BLE scanning and got that checked in yesterday. So that's the ability to, so BLE, Bluetooth Low Energy. We've talked about it before because I did a lot of the workflow stuff on the stream, but the short of it is that there's really two stages to BLE, to Bluetooth Low Energy. There's one stage where you're not connected to any other particular device, and that's known as GAP. I forget what it stands for. But it's the process of like discovering other devices around you and then initiating connections to those things. And then there's a second stage, which is usually called GAT, which is all about once you're connected, how do you figure out what the other device can do and do the things with the other device. So GAP is kind of what I'm working on first, because you have to do the scanning and advertising and connecting parts before you can get to the part of doing stuff over connections. So I got scanning working, which is what's known as the central role, which is I'm looking at what's around me and I may initiate a connection to something else. And then the peripheral role is the opposite, and that's advertising. That's saying, hey, I'm here. Hey, I'm here, and this is what I can do, or this is the information I have. So that's kind of the two main roles. And so this week on the S3, I got scanning working. And then I got advertising working yesterday as well. And I woke up to Dan having just merged it in, which is great. The scanning took a little while, but it took a while for the PR to get finished, but the advertising went pretty quickly. So the next thing on my list was doing server support. So once you're connected, you basically have two devices that are kind of peers. And this is, I think, something that really confuses people of like, when you're in that gap role of finding other things, like your one person is the central, one is the peripheral. But once you're connected, either side can disconnect, and either side can be either providing a service or using a service. And this generic access protocol, thank you, Bruce. And so there's kind of two separate roles then. Once you're connected, you can have both a client, somebody operating as a client of the other person, or as the server. So it's a client or server is the terminology that they use. And it took me a long time to like understand all these terms when I was first doing BLE, but it does. I think they ended up with the right terms. It's just really not. At least it wasn't explained well where I was looking at it. But it really is like one of the more helpful things I think with BLE is just separate in your mind that advertising, scanning, connecting part from the once we're connected, now we can discover like the servers that the other device provides, and then you can provide services as well. And when you're the person providing a service, it's called being a server, and then the client of that server is interacting with the service. There will be a pop quiz at the end of the stream. So yeah, that was the main thing that I was working on. You can see that these other PRs that I did were 7 days ago. And Pierre confirmed that it can be confusing. Oh, and Bruce linked to a punch through. Let's see what this is. Yeah. The general topology of the network stack. GAT refers to how data is transferred. Oh yeah, they even split up peripheral and central. Broadcaster versus observer. So I think in terms of BLE, and I thought this kind of from the point that I was working on it, is the power of BLE advertising and scanning, being a broadcaster or observer, is like underrated. Like people don't fully use it. I did this project a while back when I was doing it earlier called BroadcastNet. And this is what it's called here, but JP wrote it up as a guide. And the idea was that you would just have one or more devices that were just actively listening for kind of standard packets of like IoT data that not sensitive, could just be like the temperature in your house. And the idea was that when you need to, it would just listen for any of these packets, and then it would send them up to Adafruit IO automatically. And if you wanted to add a new sensor, you wouldn't have to change that piece at all. Just when you turn the sensor on, the listening piece then automatically creates new feeds and stuff and sends it up. So I think that would be, yeah, that was pretty cool. But the problem was that still the only thing that can really do like the networking side and BLE side is like a Raspberry Pi. So this guide uses a Raspberry Pi to do the BLE scanning and then writing to whatever web thing that you want. So one thing I'm very excited about and could actually do now is run the like bridge using the ESP32-S3. So it would be listening for BLE and then do a Wi-Fi network call to report it back when it hears stuff. So I think that would be pretty cool. Let's see. BLE is terrible. The terminology and the process, they try to make it better by doubling down on wrap every version. On stuff every version? Deshipu says, question about BLE keyboards. Would it be possible to make a split keyboard so that one of the halves is connected both to the computer and to the other half. I think that is possible. The thing that you have to watch out for is usually it's a compile time configuration for how many connections you can have at once. But usually you can have multiple at the same time. And Pierre is confirming that says that's what everybody that does BLE splits do. Pierre says beacons that don't actively get connected to really fit in that terminology. I wonder how much more complicated it will be with mesh. Yeah, a lot of the Linux side, particularly, like a lot of the uses for BLE advertising and scanning is really just to discover a device you want to connect to. So it's that software is not usually designed for the case where you doing like broadcast net, where like, no, I want to listen to every advertisement. I want to hear every advertisement because the data is changing and I care about the data that's changing. And if you followed any of the COVID proximity, what's the contact tracing stuff that like Apple and Google did, that's all with that's all using BLE advertisements as well, scanning and advertisements. That'd be incredibly powerful in so many use cases. Yeah. Yeah, I got what you meant by wrap. I don't know. I generally think BLE 4 and 5 have been pretty good. Will the code be interchangeable for BLE between ESP32 and the nRF52840 boards, or will there be slight variations? Hopefully they'll be the same. And yeah, deshipu says that's what Nimble thing is for. Hopefully they'll be the same. The thing that you might run into is there might be things that aren't supported. So I'll give you one example that I think we're going to have is that the ESP32, not the S3, not the C3, but the 32, can do BLE, but it's BLE 4.0, which means that I don't think it can do extended advertising. Whereas, and BroadcastNet uses extended advertising if you're sending enough data. So there might be things that although the API will be the same, it would raise an exception if you tried to do it because if it was unsupported. So yeah, I missed this little like brief thing where I was like getting really into it yesterday. And then now it's 3 o'clock on a Friday and I'm like, I don't really want to get too much into it. But we can take a bit of a look at this. I'm guessing BLE scanning and advertisements is how Apple AirTags work too. Yeah, I believe so. I believe AirTags are basically the same thing as the contact tracing stuff. And the way that all that stuff works is there's like, you provision encrypted broadcasting numbers that you're broadcasting based on like from the AirTag or your phone for the COVID case. And those seem like random numbers to most people, except if you know that the key is something or something. Like there's a bunch of cryptography around what you're broadcasting, so that like it's private. The problems that iPhones have been running into, that Apple's been running into with the AirTag privacy is really when somebody attaches not your AirTag to you so that they can track you. So Unexpected Maker says the ESP32 can advertise extended stuff because that's what they're using for the SAM, but I'm not sure if it can receive extended. Newer versions of BLE are adding parts for like angle tracking and things like that, which is fancy. Actually, maybe that's what I should do right now. Should I see if I could get this BroadcastNet bridge going? Yeah, let's try that. Let's just see if we can't get that. The AirTag main issue isn't a technology problem, it's a people one. Keith, are you saying getting the BroadcastNet stuff going would be cool? Good night, Dave. Thanks for hanging out. I think that is a good idea. It should port, so it uses BLE.io to do it. All right, let's do that. That's a good idea. Where's the source? Blinka bridge. Oh, it's just in the BroadcastNet directory. Okay, so let's see. This is my PSRAM version, so let's start here. I actually do use BroadcastNet here, but I think the Raspberry Pi that I had running the bridge is broken. So. My SAM racks send data to the Raspberry Pi from a TP Nano and MicroPython using extended advertising. Nice. Okay. So I've got this, and this was my advertising test. So it actually it advertises as being connectable, and then it just prints out when it's connected and disconnected. So I got that far, confirming that I could connect and disconnect okay. So let's find this BroadcastNet stuff. I should say that BroadcastNet is not as useful as it was at the time, because Brent and Lauren have done an awesome amount of work with Whippersnapper, and these inexpensive Wi-Fi capable, like the QT Py S2 would be perfect for this sort of stuff too. I don't know what the battery life looks like. The battery life differences look like between ESP32 and the NRF. But it doesn't really matter if you get them both sleeping pretty deeply. There is a bug / miscommunication about the way the ESP sleep works, or sleep works, deep sleep works, that I filed an issue for. And somebody had commented that when CircuitPython wakes up from deep sleep, it's on for at least 5 seconds. And that was really weird to me, because I thought the policy was that we'd only be on for 5 seconds the first time to see if you're connected to USB, and it turns out the way it's implemented, it always does it, which means that you're always awake for at least 5 seconds, even if you've been trying to deep sleep. So I filed an issue where I want us to fix that, because a lot of the challenge with low power is just being asleep for as long as you can, and when you wake up, being on as short as possible time. Okay, so BroadcastNet has some issues. I'm not going to get distracted by that. I'm just going to download a fresh bundle and snag it from there, so I can have the latest version. I don't use Circup yet, so don't hate me. I'll just download this and extract it all. So here I am in the bundle, and in examples, we're going to want broadcast, BLE, BroadcastNet, Blinka Bridge. It's called Blinka Bridge, but we're going to make a non-Blinka Bridge. So we're going to copy that. That'll be our code.py. And then we also are going to need the actual library. Let's get the stuff going here. TO dev serial by ID USB espresso. Oh, I already got it open. It's there, but let's move it to the bigger one. I aspire to that low power lifestyle. The Circup non-believer, get him. I'm a believer in Circup, but I've done CircuitPython for so long without it, as Keith points out. Workflows are hard things to change. Like fundamentally, the way I program by like using the command line and an editor that doesn't do fancy type stuff is like very much like the way that I started. Printf debugging is like, it's just the way I've always done it. I wonder what things I have actually incorporated. That would be interesting. A lot of it's the same. I've been doing Python for almost 20 years, I think. Huh. If your iPhone supports Ultra Wideband and your AirTag is nearby, you can use precision finding to help find it. Fancy. I've been a Vimmer for decades. Yeah. Oh yeah, Unexpected Maker points out you can import Adafruit's Eagle files into KiCad. That's actually how I was using it. That explains why I couldn't import PDB. Yeah, I've never used PDB myself, and so that's not something I felt like, oh, I've got to have this. I did start using f-strings everywhere, which is cool. Okay, let me rename this code.py. This is my workflow too. Advertising simple tests. And then I want to use this, so I'm going to rename this to code.py. C. Gerber says, the footprint is fairly easy to create. I have a few different 2-layer designs with custom silk layers in KiCad. Did not work. There's this lag that I don't know where it comes from. Sometimes I need to do a sync to get it to write the full file. No module name secrets. Yeah, it needs my... I don't want to show my Adafruit IO credentials. That's why I pulled it off the screen. But I might have a copy of the... No, it would be on the Raspberry Pi. Let's just not do that right now. Didn't KiCad 5 have import as well? I'm just going to comment out secrets here. I don't actually care to do the Adafruit IO pieces right now. No requests. Actually, I could copy requests over though. Oh, it might be importing regular requests. Import Adafruit requests as requests. This conversation shows why Discord is great. Ooh. Just curious, I haven't looked into this, but is there any good libraries for creating and managing SQLite databases on CircuitPython hardware directly? So somebody made a micro SQLite for MicroPython that looks really neat, and I would totally be game to have in CircuitPython, but I haven't looked into it. So yeah, I would look in MicroPython land for SQLite stuff, and it would be super neat to have it in CircuitPython. But we don't yet. So Adafruit BLE broadcast net is not available. So let's do that. Yeah, I would like this to, oh, it must be a single file. It would be cool to have this supported. Name secrets is not defined. Yeah, I'm just gonna comment everything out. AIO auth header. Where is that? 994. Existing feeds. Let's just... I just want to print it out. Actually, I wonder if there's a simpler... Oh, well, it started up. Scan done. Does it have a timeout? I don't think it's supposed to have a timeout. Does start scan have a timeout now? I don't know. I was wondering if, I think I have, oh no, you know, I think I disconnected the sensor downstairs. Okay, let me update this other. Let's get 2 going and see if we can't get both ends working on a S3. So I've got here another board, but this is a mini. I think this is one that doesn't have any RAM, so I'm gonna have to make sure I load the right thing onto it. And in fact, I'll do it on the UART. That is an N8, yeah. So let's go here, make, and then let's not do debug. Oh, and oh, I guess that is right. So we'll build and flash that. For a recent project, I ended up just logging data to a text file on the CircuitPython hardware. Then I made a Python script on the computer to parse and append data to a SQLite database. That's a good intermediate fix, but it would be cool to support SQLite. I'm a huge fan of SQLite. I like that I don't have to worry about running a database primarily. All right, so we should be flashing, well, we're building and then we'll flash the PSRAM list version of CircuitPython onto this second board, and we'll do the broadcast net. I don't know, have we hooked up the temperature sensor yet? But we'll get it broadcasting out, and then we'll have one listening as well. And the idea with BroadcastNet is that you don't have to change the bridge or any of the software to add new nodes, which is cool. And then one of the other things I was thinking is that when it logs to Adafruit IO, it will log to a bridge-specific feed as well. So you can actually, if you have reliability problems where like I live in a 3-story house, I'm on the 2nd floor. If the node is on the other side of the house and I only hear it once in a while, I could actually make another bridge closer to it, and then they both kind of independently report the values that they hear. So it's like another, like, you don't have to worry about everything else. You just add another bridge, and therefore you get like some redundancy in listening for values. I really think BroadcastNet's pretty neat, but then again, like if you have Wi-Fi, you could just all do it with Wi-Fi. But I think at the time we did BroadcastNet Bridge, maybe that was pre ESP32-S3 actually. When was that guide written? There's 3 unresolved feedbacks. I'm so bad at that. First published 2020. But the ESP32-S3 came out after that, right? March of 2020. I have no idea. The Feather came out just recently. MagTag we did a lot of work for. And that's November of 2020. So yeah, I think throughout 2020 is when we're doing the S2. Is that right? Funhouse is S2. April of 21. Yeah, that must be it. Yeah, I think we must have done BroadcastNet before we had Wi-Fi. What's your standard work regarding compiler warnings? Generally, I fix them, but the compiler warnings you were seeing go by are ESP IDF ones. So I was ignoring those. Okay, so we're flashed. And now I'm just switching to the other USB port for native USB. And I should get a second CircuitPython drive showing up here. So let's see, what do we want to put on this? So here it actually shows up as CircuitPy1. Hey, and you can see my Wi-Fi password. Don't come to my house. That's not cool. Let's close that and rename it. That was the Wi-Fi test. And then let's look in bundles examples. BLE, BroadcastNet, exponential backoff, simple test. Oh, there's a scan test. That's probably what we should be using. Copy there. Rename. Code.py. And maybe what we do is we split here and we do another TO dev serial by ID USB espressif no R. I really like this serial by ID. It's really nice. And let's just Control D it. I don't know why Control D is so slow. Okay. Unexpected Maker just did a PR for their new S3 boards for TinyUF2. Haha. Really? Remember that magic you did on the CircuitPython repo to not build every board on every PR? Time for that on TinyUF2, I think. You could do that. Or you could file an issue on the TinyUF2 stuff and point to it. It's not too hard, but does TinyUF2 split jobs? Split board jobs? I don't even know. But yeah, I'm excited for your PR for CircuitPython to support your new S3 boards. So we're grabbing the library, BLE broadcast net, copy there, restarted, and now it needs the BLE library. You folks who use Circup are probably, your heads are exploding right now, aren't they? Not implemented. Working on that right now. Yay. You need GitHub Actions foo for the build what changed stuff. All right, so let's see what is on line 16 here. Oh, CPU temperature is not implemented. I could do that. First, let's just try setting it 40. I'm surprised we don't have CPU temperature, actually. Yeah, so the way that this works, so the way that Broadcast Net works is that it has a sensor measurement advertising class where you can set a value on it, and then it also, oh, I don't include the sequence number. But there's a sequence number slot so that you can increment the sequence number, and your bridge or your data that's with the bridge can know when it misses things. So you can get an idea of like how reliable it's transmitting. So let's go over here and do scanning, broadcasting. Ha! Yay! It found it. It just crashed. I don't know why it's not infinitely scanning. I have microcontrollers scattered all over my desk. I have bins per manufacturer, so I have a giant bin for SAMD and STMs, and then I have like a overflowing bin for ESPs and NRFs. That's kind of how and then I have a separate place for Adafruit specific boards and all different ways of organizing them. And a lot are on my desk right now too. All right, so let's continue trimming this down so that it create group. Missed message counts. Create feed. See if that does it. So this is successfully like broadcasting every so often. It's completed. It should be scanning forever, I thought. Oh, there's one. It went real fast because it didn't actually log in. But here's like the feed name. So it's the MAC address of the, it should be the MAC address of the bridge and then the MAC address of the sensor. And then here's the different values. You have missed message count, so that's based on sequence number. And then you have like the field, the temperature, and what the value is. So they have the one caveat is that they have the same notion of what the fields in the Adafruit sensor measurement are. So we have two things we could do in the next 25 minutes. One is I could try to get CPU temperature working, which I'm surprised does not work. Let me just look at that first. And then the scanning is the other thing that I would like to figure out. So the CPU temperature is going to be in Common Hell, microcontroller processor. Processor get temperature. Oh, I'm in NRF. I'm like Bluetooth soft device. That's not the right place. Espressif. Do we really not have CPU temperature? That surprises me. Processor. Oh, does the S3 not have the ability to measure it? Or it's just not implemented. Paging unexpected maker. Can we read the CPU temperature of the S3? It's really nice to have. This is for the C3. Yeah, they at least have these nice caveats that it's really not the external temperature, but it is really nice to have a sample source. S3, Wi-Fi, Bluetooth peripherals, not supported. IDF-1793. How do we find that? Touch sensor. The Israel Defense Force. That's not what I mean by IDF. Doesn't look like it. It might not be supported yet. Don't they have issues? Oh. They have an internal bug tracker too. Not sure how to read it. Thank you, Unexpected Maker. Ooh. Yeah, that doesn't look like the IDF supports it yet. Which means that I'm kind of at a loss. We could look and see what the datasheet says, but I don't think it's worth it. Could just be like, hey, like, we care about this. We'd like to use it. It's great for demos, like this one. For now, let's just take a look at scanning, because I thought infinite scanning should work. So let's go into BLE.io, adapter, start scan. Oh, there's this, not yet in 4.4. Not supported in 4.4. I wonder if they added it. I wonder if we could backport it. It probably depends on some other stuff. Bummer. Thanks for the reference, Unexpected Maker. I appreciate it. All right, well, not implemented error is the right thing to do. In that case, let's turn on BLE debugging. So in CircuitPy, config make, is this where it is? Verbose BLE. Here we go. So I have some debug statements that are behind this verbose BLE flag. And then let's add a debug print to, where's the scan event? So here's the unsupported scan event. And let's just do a print here too, scan done. To know that that's what's finishing it up. And then I thought that timeout here, timeout times 1,000. Timeout times 1,000. Let's just print it out. So let's see, which one are we talking to? This one's still going. This is the one that keeps finishing. Just this one, I think. So I'm not using the UF2 loader at all. I just do the flash thing. Really need to clean. 8. This one? Yeah, that's the one I wanted. Oh, I can't see YouTube chat. Is it probably not looping because the timeout for the scan isn't defined? Yeah, I don't know what the default value is. That's something I will look at. Because the library could be adding a default value, or the native code is. So we can look in shared bindings to see what the native code does for timeout. So BLEIO adapter, start scan. It says, timeout optional float none. And then timeout none. If timeout is not none, get it. Otherwise, it looks like it's set to 0. It checks to make sure that it's not 0. If timeout's not equal to 0, make sure that it's less than the interval. So I think what we would expect is it to be 0. Right. So, okay, we're here. Oh, it didn't work. Pro tip, if you try to flash from here and it doesn't work, it's because your connected via the serial link. Yeah, we could backport if they've added it. If they've added the temperature read in 5.0, we could probably backport the code from there and just like directly into our stuff. Yeah, Roy, it sounds like you have a KMK problem. I think that's the conclusion deshipu will come to you. If you can use Neopixels straight with your RGB, but they can't with KMK, then there's something weird. Okay. This process takes a little while. Flashing to the ESP. I just put headphones on and I'm just like going when I'm doing this. All right. So I'm connecting that up. Restart this. USB's live. The bridge heard it. Okay, so we got 2 scan done prints. One thing that's interesting is that the capitalized scan done was printed before the other one? The other one is in the callback, which is what I would expect to show up first. Let's hit Control D to rerun it again and we'll print out the timeout. Scan timeout 0. So I wonder if it's weird that this scan done happens before the other one. Right, so if we look at adapter, scan timeout is 0. We should double check that the Nimble API. Oh, wait, I did capitalize it. Okay, so it is doing discovery complete. And so we need to figure out whether BLE gap discovery, what happens if we give it a timeout of 0? There might be a different value that we want to indicate forever. So the place to look for that is I actually have 2 text windows open, and the second one here is with the Nimble API. There's one that I'm editing the code.py stuff in. So there's BLE gap H, and that's where discovery call is. Duration in milliseconds. Specify 0 to use the stack defaults, right? So we're not doing forever, we're doing stack default. So what we're going to want to do is we're going to want to do this BLE HS forever, which I'm curious what the value of that is. Oops. Get RG that. Int 32 max. So it's not actually forever, it's just in 32 max. So what we can do here is in our adapter code, now that we know this constraint about 0, we can say, let's call this timeout ms. We could even call it duration to match. Duration ms equals that. I'm not going to print it out anymore. Good, this will be a nice small fix. There, and then we can say if duration ms equals 0, we mean BLE HS forever. Forever. Which, let's see, how many milliseconds is int32 max? Because that's kind of interesting. If you're meant to like set this thing up for a year and just let it run, like how long would it run until it actually stops? Because it's in 32 max. 0 equals forever, or a 32-bit max is practically forever. So 0 is meant to mean forever in CircuitPython. In NIMBLE, the BLE stack that we're using, it means the default value, which is not forever. Which is why we're doing this. So let's disconnect again and reload. Usually I'm not switching the USB back and forth. I usually have just 2 of them plugged into the same side. Are you asking us to solve the halting problem? No. I'm not trying to determine if it'll halt or not. I guess they could special case it later to mean, like, I don't know whether they internally track the timeout or not. Sorry to keep you awake, Tanu. Feel free to sleep on stream. I do some weeks and folks don't even realize. It's just Friday afternoon, I'll tell you that much. What are the units on the timeout value? I think they're microseconds, yeah. Or milliseconds. I think they're milliseconds. Microseconds would be US. Does CP equal NP? Oh man, there's computer science people in the audience. Halting problem and P equals NP. That is a long time then. Okay, great. Friday afternoon, Yannis. 24 days if milliseconds. But yeah, that's not that long. It is signed as well. So it's 2 to the 31. It's not unsigned. It's like almost 80 degrees in here. That's part of the reason why I'm sleepy. It's nice and warm. All right, let's switch it. This will be a good thing to go out on if it works. All right, so we plugged it back in. Let's switch to here. CircuitPy drive showed up. I guess I could get the networking stuff going. Good night, deshipu. Sleep well. Sleep well. All right, we're getting multiple sensor readings in. "24 days is forever to the average Zoomer." But like the point of this thing is that it's meant to just run forever. And that's like thousands of TikToks. Are we just measuring everything in TikToks now? Is that the unit we should use for time? How many TikToks? Cool, well this is working. I feel like I should show all the I/O integration, but I don't really feel like figuring out what my I/O keys are. Which is why... Oh, I'm being yawn again. Sorry. As is, it's really neat. Thank you, Keith. I feel like I should, while we're talking about it, I should put a while loop around it. Like, I don't ever want to get to scan done. Actually, you know what we did look at? We tried to see if it's used in examples. Like, it could be used as a sentinel value in 32 max. Yeah, I don't actually, uh-oh. Something disappeared. I think I'm in safe mode. Uh-oh. What happened? Assertion format not equal null failed. I saw this before. I was trying, format not equal null. That doesn't make any sense to me. How do I figure out what devices can listen for these advertisements? What version of Bluetooth do they need to have? So Bluetooth 4.0 should work okay. That's without extended advertisements. I think I actually added a thing to prevent you from going over the limit of extended advertisements, because if I remember right, I don't think the Raspberry Pi can actually listen for extended advertisements. So I think if you try to send too much data, it will actually just do, if you do too much data, then it will actually just do multiple advertisements to like push out all the data. But yeah, version of Bluetooth, I think like 4.0, like any Bluetooth low energy should work. It's just advertisements and scanning. CPython you can run with -C1 to turn off assertions. Yeah, this is a debug build. That's part of the reason. And I should figure it out because I saw that. It has to do with printing out an exception. I added this cool thing yesterday. There's this, not in shared bindings. I added this check NIMBLE error, and it, oh, you know what? I don't know what that is from. I thought it had to do with this, but it must be a different exception that it's having a problem with. But I came up with this. So there's this check NIMBLE error, and then it takes file and line number. And then I added a macro check NIMBLE error that automatically adds the file and line number. It's really, for my debugging yesterday, it was really handy. So like there's a lot of calls, like for doing one thing, there may be like 3 or 4 calls to NIMBLE in order to make it happen. And so you could just say like after each of those calls, I say check the return. And in proper CircuitPython, it'll raise an exception. Well, what it does, it raises an exception, and if it's a debug build, the exception string includes the line number and the file number of the exception and the error code. So that was really handy. Keith says, this is exactly a branch of project I can see a lot of labs using. First grad students building a coffee monitor, then quickly scaling to other small monitoring tasks. It's so neat how easy it is to set up and get running. That's the hope. Yeah, so extended is just longer. Pierre says, I use NRF Connect on my phone to see the whole list of what's around me. The list is crazy long where I live, and I don't even live in a condo tower. Yes, that's why I did scanning first. It's because like if scanning is working, you get a lot of results. So yeah, you can now use the ESP32-S3 to do scanning stuff as well. But yeah, this has been super nice. And I don't know why this assertion is happening. I think it's something separate. It is weird that it went into safe mode. It would be great to see a backtrace of like what is handing in a null format. I thought it was the file name thing, but I could be wrong. I don't know. I think we successfully finished the scan stuff. So I could just do a quick... I'll just call it. I'm toast. It's the weekend for my brain. Let's switch over to the camera. And notes. So thank you everyone for another deep dive. As a reminder, I'm Scott. I'm sponsored by Adafruit to do these streams and to work on CircuitPython. If you want to support them, go to adafruit.com, purchase some hardware there that looks neat to you. You could find something that is a project that you've always wanted to do there. There's lots of tutorials and stuff. If you'd like to chat with me and a bunch of others working on CircuitPython and all sorts of different things, you can join us on Discord at Adafruit, adafru.it/Discord. That's our short link for Adafruit. Yeah, we're on there, and that's what this middle box that I can't point to is. That's the Discord channel of live broadcast chat. We'd love to have you there. The other streams, chats disappear at that point, so that's why Discord's great. Deep dives happen every week, normally Fridays at 2 p.m. Pacific, unless I take the week off. Next week should be normal, so 7 days from now, 1 week from now, we'll have another deep dive. Hopefully I've made a lot of progress on connecting over BLE. That would be great. Typically it goes for 2 hours or more, right around 2 hours today. I'll look at Unexpected Maker's PR next week. I won't wait for it, but they're just about ready, so that's exciting. Last up, all notes are available on GitHub at github.com/adafruit/deep-dive-notes. Thank you to DCD, David, for taking those notes for us. And thanks for Patrick for automating the scraper and maintaining the scraper and getting all of those notes in there and linked up. It's super helpful. So with that, I will thank you all. I'll switch to cat cam, give the cat a pet, and then call it a day. Have a great weekend, everyone. Cat cam. Cat cam. Oh boy. Sound asleep, but the sun's gone. More often than not, after the stream, he gets on my lap because I just got him interested in more pets. All right.